Part 6 of our first unit is classifying matter. So we're going to get into understanding matter itself by categorizing it. So matter, first of all, is anything that has mass and volume. So anything that has mass and takes up space. Which means the things that aren't matter is a pretty short list. Energy, visible light, X-rays, UV, all that stuff. But also time, gravity, just things that they themselves aren't made up of atoms, essentially. Mass versus weight. So an important concept to understand is that mass and weight aren't quite the same thing. For most of our purposes in the lab, we use them pretty interchangeably, but understand that mass is the amount of matter present in an object, and it does not depend on where you are measuring it. So in other words, you could measure the mass of something on the moon using a balance, and it's not going to change. But if you're talking about weight, weight specifically refers to the force of gravity acting on an object, so it would be very different on the moon and have a smaller weight. So thinking about how we split up matter, if you have something that you know has mass and volume, so you know it's matter, what are some different ways to think about it and subdivide it? One way is to categorize it as either a pure substance or a mixture. Okay, so a pure substance means that you can't break it apart by physical means. You can only break it apart by chemical or even a nuclear reaction. Okay. Whereas a mixture they're just physically combined. So think about salt water, for example, would be a mixture because you could boil away the water and leave behind the salt. That's a physical process. So it's very easy to separate them into the pure substances in that salt water. Now, among pure substances, you could also further break them down as either element or compound. And of course, you guys already know what elements are. They're just the substances on the periodic table. So an element refers to like a pure chunk of copper or gold or some hydrogen gas. They're made up of only one kind of atom, right? Whereas a compound would be two or more elements chemically combined, H2O, CO2, and so forth. But even though they're made up of multiple elements, they are chemically combined, chemically bonded. So you can't just boil water and separate hydrogen and oxygen because boiling is a physical process. You would have to do a chemical reaction to separate those two elements from each other. Mixtures can also be subdivided. Sometimes a mixture is heterogeneous and sometimes it's homogeneous. And the prefixes kind of explain it. Hetero means different. So if a mixture looks different throughout, like if you can imagine like a really rough sand mixture with larger pebbles and different colored pebbles in the mixture, you know that it's not made up of one pure substance, right? So it's an obvious mixture. Whereas homogeneous is well mixed. So if you can imagine, paint after it's been mixed at the store when you first take it home is very homogeneous. Salt water, right, is going to be homogeneous. You can't really see the salt. You can't see it until you actually boil away the water and leave the salt behind. Okay, so if pure substances if you can't see the element or compound's chemical formula, to know that it's a pure substance, you have to know that it has constant intrinsic physical properties. So if I have a piece of gold, right, one of the intrinsic properties of gold is that if it's pure gold and you press into it with your fingernail or bite it like they do at the Olympics, right, when somebody wins a gold medal, what you're demonstrating is that you're testing to see that it is in fact pure gold because pure gold has the intrinsic property of being very soft. It has a very low hardness for a metal. And that's considered an intrinsic property of gold, which is why we use it to identify gold. So an intrinsic property just simply means a property that can be used to identify a pure substance because that property never changes. So for example, the boiling point of water, assuming it doesn't have anything mixed in with it, assuming that it is in fact pure water, the boiling point of water is 100 degrees Celsius. So that's an intrinsic property. Okay. Other examples, melting point, we already said boiling point, density, color, electrical conductivity, reactivity, solubility in water, so does it dissolve very well in water, that kind of thing. Extrinsic properties are the opposite of intrinsic. So extrinsic properties are those that vary between two samples of the same pure substance. So for example, the mass of a sample of gold, or even could even be a gas. The mass, the volume, all of these things can change, and you still have that pure sample of gold, right? Not every piece of gold is the same. Not every piece of carbon is the same size, shape, mass, but they all have, carbon has a constant melting point, a constant electrical conductivity, and things like that, because those are intrinsic properties. All right, now we're going to be in the lab later on figuring out how to separate a mixture of pure substances. And we're able to do that because mixtures are made up of two or more pure substances, and we already know that pure substances have unique, constant, intrinsic properties. And so we can use those properties to separate a mixture of pure substances. So I described earlier boiling away the water in a saltwater mixture. What you're doing is you're taking advantage of the fact that water has the intrinsic property of boiling at 100 degrees Celsius, whereas salt has a much, much higher boiling point, right? So you can set the burner anywhere above 100 degrees Celsius, maybe 150, 200 Celsius. You're going to boil away that water, but the salt is not even going to melt. It's going to be sitting there as a solid when you're all done, because salt and water are each pure substances with their own unique boiling points. So distillation is an example of a process that is using the intrinsic properties of pure substances. So if you have like a salt water mixture or an alcohol and water mixture, alcohol is another one where alcohol will boil at about 80 degrees Celsius. So it will boil away. If you have a mixture of alcohol and water, the alcohol will boil away first, and then you can capture it and condense it back into a liquid and pour it into this, or let it drip into this other little beaker. And so that's going to leave you with pure alcohol separated from an alcohol and water mixture, and the water would be left behind because you're not heating it up to its boiling point. Eventually, of course, if you heated it with the flame, you would certainly boil away the water, but the alcohol boils away first. So that's what distillation is. Another one would be just filtration. So even something as simple as filtering coffee, you're just taking advantage of the different sizes of the particles, and capturing some of them onto a filter or filter paper. So that's one way to separate a mixture. Usually that one is going to be useful for a fairly heterogeneous mixture. So the larger particles are left behind, and the smaller particles or the water or whatever can go through the filter. Another one is decanting. So what this is if you have two liquids, or let's say a liquid and a solid, like this looks like it's maybe sand or mud in water. If you let that heavier, more dense solid fall down to the bottom, and then carefully pour out the lighter liquid from the top, you will leave behind the heavier sand at the bottom, right? And so that process of taking advantage of the different densities of the two substances in the mixture is called decanting, and we'll actually get a little bit of practice with that in the lab. And then this is, again, these are just 4 examples. There's lots of examples. But a separatory funnel, this would be if you have 2 different liquids of different densities, and you want to extract the heavier one. So rather than pouring off the lighter one, which can be tricky because liquids tend to, mix pretty well as you're trying to pour them, but you can allow them to separate by their densities, and just kind of open a valve down here at the bottom and just pour out the heavier, more dense liquid. And so again, all of these are just a couple of examples of taking advantage of those intrinsic properties that are specific to each substance. And we'll learn more about that as we do this in the lab.